Hello everyone and welcome to day 20 of Python for Beginners tutorial. In this tutorial, I will delve into the fundamental concepts of object-oriented programming in Python. By the end of this tutorial, you will be able to understand what is object-oriented programming and what is object. Before that, don't forget to like, share, and subscribe, write comments below. Let's get started. What's the object-oriented programming in Python? Object-oriented programming is a method of structuring a program by bundling related properties and behaviors into individual objects. It is a programming paradigm that provides a means of structuring programs so that properties and behaviors are bundled into individual objects. In Python, everything is treated as an object, including variables, functions, lists, tuples, dictionaries, and set, etc. For example, let's say a variable x that stores a value of 42, and we can determine the type of this variable x using type function. And 42 is an object of an integer, and every object in Python belongs to its own class. For example, this integer belongs to the class. An object is simply a collection of data or variables and methods, functions that act on the data. For example, this integer object is stored in a variable x. So every object has its own properties and methods. For instance, an object could represent a person with properties like a name, age, and address, and the behaviors such as walking, talking, breathing, and running. The properties define the state of the object. For example, the property name defines a person object, and the behavior are the action that the object can take. Oftentimes, the pairs involves using or modifying the property of that object. For now, we can think of an object as anything we can store in a variable. For example, this integer data stores in a variable x. So this is called integer object. This integer object belongs to its own class. Let's add one more example. X stores a string. And let's determine the type of this string object. So this is a string object. This string object also belongs to its own class because every object belongs to its own class, and we can have objects with different types. So we will talk about class later on, but in this class, we will just discuss what is object and how we determine the objects as well. We already know that integers, strings, lists, and dictionaries behave differently. They have different properties and different capabilities. In the language of computer programming, we say they have different attributes and methods. An object's attributes are its internal variables that are used to store information about that object. So this integer object could store the information about integer. Okay. Let's add one more example. For example, the complex class with the numbers. So this complex number has real and imaginary parts with the formula of a plus bi. A and b are real numbers, and I is imaginary. Okay, so this complex object has its own properties and methods. For example, if you want to get the imaginary and real number of this complex object, we can use the attributes real, for example. So the real number is 3 in this case, and the imaginary number is x dot imag. Okay, that is 4. So real and imag is the properties of this complex object. We can determine the type of this object using type. That is complex. So this complex object belongs to its own class. So this object has its own properties or attributes, for example, real and imaginary. Okay. And it also has its own methods that used to manipulate the complex number. An object methods are its internal functions that implement different capabilities. For example, let's say we have a string object. So this string object has different methods. For example, if you wanna convert the string into uppercase, so that string object has the method upper. So this converts into uppercase. There are many more methods that use to manipulate these string objects. So we will interact with an object's methods more often than its attributes. So the attributes represent the state of that object. For example, this real and imag are the attributes that represent the state of the object complex. We usually prefer to mutate the state of an object via its methods, since the methods represent the actions one can take happily without breaking the object. Often, the attributes of an object will be immutable. For example, the method that mutates an object is the append method of a list. Let's say we have a list. And if you want to mutate the object of this list, first of all, let's determine the type of this X. So this type is list object. So this list object has its own properties and methods. And this list object belongs to its own class. Now let's mutate this list object using its own methods. For example, if you want to append a new element in the current list, you can use x.append, and you can pass the elements to be appended at the end of the current list. And when you print out that list, you can see that this new element is added in the current list. So this is called what? Mutating the objects using its own methods. Okay. The other is how do you know what the attributes and methods of an object are? We can use the Python's ER method that used to know what are the attributes and the properties of or methods of that object. For example, here I have list object, and I can see that there are a lot of methods and attributes in this list object here. For example, the append method is here, clear, copy, count, extend, and so on. You can use the dir function, which is a powerful and built-in function in Python 3 and above, which returns list of the attributes and methods of any object, including functions, modules, strings, lists, dictionaries, etc. So those are today's lesson. I hope you enjoyed this video. See you in the next tutorial. And this tutorial, you will be able to understand what is class, how to define class in Python, how to instantiate objects of that class, what are attributes and methods in the class, and what is constructor and instance attributes and the init method in object-oriented programming in Python. A class is a blueprint that defines the variables and the methods common to all objects of a certain kind. For instance, we can think of a class as a sketch or prototype of a house. It contains all the details about the floors, doors, windows, etc. Based on those descriptions, we build the house, so the house is the object. As many houses can meet from a house's blueprint, we can create many objects from a class. So an object is called an instance of a class. And the process of creating this object is called instantiation. Why we need to define a class in Python? For example, let's say you want to track employees in Coca-Cola company. You need to store the basic information about each employee, such as their name, age, position, salary, and the year they started working. One way to do this is to represent each employee as a list, look like this. So there are a number of issues in this approach, because let's assume the Coca-Cola company has over 10,000 employees. And to store each of the details of the employee in a list, you could have 10,000 variables, which stores each of the employees' profile. So this make larger code files more difficult to manage. If you reference profile at index 1 in the first list, for example, it prints the age of that employee. But when you refer the second list at the same index, it prints male engineer, which is the position of that employee. So in this case, the two lists have no equal number of elements, but they work at the same company. And in the second list, age is missing. So this is a challenge. So it is difficult to track each of the employee details using such kind of way. So the great way to make this type of code more manageable and more maintainable is to use classes. How to define classes in Python? You can use the class keyword and the name of the class. So a class is created by the keyword class. An object is created using the constructor of that class. So this object will then be called the instance of the class. So this is what creating objects of the class, my class. So this is a constructor. To instantiate the object of the class, we use the constructor of the class. A constructor is a special method that is used to initialize a newly created object and is called just after the memory is allocated for that object. It can be used to initialize the object to desired values or default values at the time of object creation. So this is called the process of creating objects for the class, my class, which is the instance of the class. When you are creating classes in Python, you can use capitalized words, which is naming convention. So for example, this is my class. The class has two consecutive words, and I used capitalized words to create a class. Okay, the other is attributes and methods in a class. Every class should have attributes and methods to store information about that object. So a class by itself is of no use unless there is some functionality associated with that class. Functionalities are defined by setting attributes of the class, which act as containers for data, and functions relate to those attributes that take an action of that object. So the functions which are set inside the class are called methods. Let's implement a class called rational. So this class has an attribute of frac, which store the data of fraction numbers. Then I just instantiate the object of this class, and I can access the attributes defined inside the class using the object of the class and dot operator followed by the attribute name defined in that class. So to access and print out the values stored in this attribute, I can use the instance name dot the attribute which is defined inside the class, for example, frac. So the information is now printed out. Once we set an attribute in this class, we can able to create the object of the class as you're seeing here. And we can assign the class to a variable like this. This is called what? Object instantiation, which is the process of creating object for that class. So you will then be able to access the attributes that are present inside the class using the dot operator and call the name of that attribute defined inside that class. So far, so good. And once there are attributes that belong to the class, you can define functions that will access the class attributes. These functions are called methods. When you define methods, you need to always provide the first argument to the method with a self keyword. For example, in this rational class, we can define the attributes of the class, numerator and denominator. Then, to access the attributes of this class, we can define the function which is called methods. The first argument of this method is the self keyword, and we can pass other arguments. So in this case, we can access the attributes of the class using the self keyword inside this function or method, and we can assign the arguments of the function into the attributes. And the function going to return the fraction of the numerator and denominator. Now we have finished defining the function or the methods of the class, and this class going to return the result of this fraction when you call that function. To access these methods of the class, we can use then we call the function fraction, and this function has 3 arguments, but the first argument is the instance of the object or the class, which is instance name. We don't need to pass any value for the first argument, self keyword. When you are instantiating the object of the class, it automatically assigns that instance name to the self keyword. And we pass the 2 arguments into this function. For example, 4 and 5. Then we print out the result of the function. Now we get 0.8 as a result of this function. So those are the attributes and methods of a class. So we can define many more methods to perform different actions. And we can also define different attributes of the class, because every class has the states and behaviors of that object of the class. So this self keyword represents the instance of the class. By using the self keywords, we can access the attributes and methods of the class in the Python object-oriented programming. This allows each object to have its own attributes and methods. Now, let me show you the instance attributes and the init method. We define how the class rational should work with a special hidden method is called init. So you can comment this attributes because we can define the attributes of the class in the init method, which is the render method, or we sometimes call constructor of the class. Okay, so it takes the self keyword in the first argument of the render method, and we can pass the attributes of the class through this constructor. Okay, so in this case, you can, for example, you don't need to define this. And here, where you are calling a constructor, you need to pass the arguments of the constructor, because we defined the constructor here with two arguments, numerator and denominator. So we need to pass values for this constructor arguments 4 and 5. In this case, the fraction will not need to assign any arguments. We can access the attributes of the class through the constructor. Okay, so that is similar with the previous one. All right, so this is what the init method, or the render method, that is one of the reserved methods in Python in object-oriented programming. It is also known as constructor of the class. So the init method can be used to just instantiate the object of the class. And when it is called, an object is created from the class, and access is required to initialize the attributes of that class, which is the self keyword. There is also another method, that is RPR. This method is basically used to tell Python how to print out the object. In this case, it will just print when you are printing the objects only. You see, when you are printing the object, it just prints the hidden method RPR, which tells how to print out the objects of that class. Those are the instance attributes and the init methods. Not only this, there are a lot of hidden methods in Python class. So you can work on object-oriented programming more and more in practice, and develop a big program that will solve a problem. For example, a company employee database, okay? Basically, object-oriented programming is very useful to just solve big problems. So I hope you enjoyed this video tutorials about class and object-oriented programming. And in the next class, we will see about inheritance. Welcome everyone to day 22 of Python for Beginners tutorial. In this day 22, I will explore inheritance in Python. After completing this tutorial, you will be able to get understanding what is inheritance and how to implement inheritance in object-oriented programming in Python. In OOP or object-oriented programming, inheritance is the capability of one class to drive or inherit the properties from some other class. Inheritance allows us to define a class that inherits all the methods and properties of the superclass. There are two concepts in inheritance. One is the parent class. The parent class being inherited from, or is called the base class, we sometimes call the superclass or general class. And the other is called child class, is the class that is inherited from another class is called derived class. So this child class going to be inherited from the parent class that inherited the properties and the methods from the parent class. So first of all, let's show you how to create a parent class. So I'm going to show you creating a parent class called rectangle. This rectangle class has two attributes and some few methods that are going to access the attributes of the rectangle. Let's define the attributes of the rectangle. So the constructor of the rectangle objects, which are width and length. And let me access the attributes of the rectangle through self keyword. The self keyword is the instance of the class. And then this base class has some few methods, for example, area and perimeter that are going to access the attributes of the rectangle and return the areas of rectangle and perimeter. So we can instantiate the object of the rectangle and access the methods of the rectangle, which is the base class. And pass the arguments through the constructor of the rectangle. And print by accessing the methods of the rectangle using instance name. So that is area of the rectangle is 200 because area of rectangle is width times length, and perimeter of the rectangle is 2 times the sum of width and length. Okay, next I'm going to show you how to implement inheritance. In this case, I have a class a square, which going to inherit the properties and the methods of the base class rectangle. This is what inheriting the objects of the base class. So this is what called child class or derived class, which derived this from the base class. So this square is also a rectangle, but it's somewhat more restricted in that it has same height as length. So we can subclass a rectangle and import this in our code. Let's define the constructor to access the objects of the superclass. And in addition to accessing the superclass properties and methods, the subclass also has its own methods and attributes. So for example, length is the attributes of the subclass. And then we are going to use the super function that used to give access to the methods and properties of a parent or superclass. So it returns an object that represents the parent class. Super, and we can use the class name of or object name of the subclass and the object itself. Now we can use dots, which means the dot operator is that used to access the methods or properties of the superclass. In this case, it's going to return or give access to the objects of the superclass. So what are the attributes of the superclass? There are two attributes in the superclass, width and length. So we take the both width and length as a length because area of a square is height times length, and the height and length are equal. All right. Now I can also define its own method, for example, area. In this case, I don't need to just calculate or use the formulas to calculate the areas. I can inherit the methods defined in the superclass through super function. And it's going to return the area of the square. So this area is the method is defined in the superclass, and the superclass method is going to return width times length, and I just replace the width by length in the subclass, and I need to pass the argument of the length through the constructor of the subclass. And now going to instantiate the object of square and pass one argument only, for example, 20. And now I just print it goes area of the subclass. Now calculating the area of the square is 16 because this area 4 is the length of the square and automatically assigned to the width of the rectangle because I'm accessing the object through the super function in the subclass. Okay. And we can also access the perimeter of 2 times 4 plus 4 is 8, 8 times 2 is 16. Okay, that's the perimeter of the square. So because I already inherited all the methods and properties of the superclass in the subclass, so I can access whatever defined in the superclass. Okay, everything can be inherited in the subclass, and the subclass also add its own additional features. Now that we understand objects, classes, and constructors and inheritance, object-oriented programming is a perspective that programs are essentially about the creation of objects and the interaction between objects. In object-oriented programming, almost every piece of code either describes an object's attributes, or an object's methods. So keep in your mind of the perspective object-oriented programming that can help us understand what's happening in our program. So these are inheritance concepts. I hope you enjoyed in this video tutorial. Don't forget to like, share, and subscribe, write comments below. Thanks for watching. Hey everyone, welcome to day 23 of Python for Beginners tutorial. In this tutorial, I will show you how to implement object-oriented programming concepts by building a library system. Object-oriented programming brings structure by modeling code after real-world objects. But today's focus is on a powerful object OOP concept, which is called inheritance. It lets us create new classes based on an existing ones, making our code more organized and efficient way. In this tutorial, I will show you a step-by-step how to implement this object-oriented concepts by building a simple library system. So this project models a basic library system with books and magazines. So the project will have three classes: book, magazine, which inherits from library class. So let's get started. First, define the base class. The base class has two attributes, title and author, and one method that's going to display the information about the library. Okay, this library item class, which is a base class or super class with attributes of title and author. It has a method display info to print the information about the library item. Next, I'm going to define the class book, which is a subclass of library item with an additional attribute January. It also overrides the display info method to include information about the January. Okay, this book class is a subclass of the library item class. So this subclass inherits the properties of the base class, which is title and author, and also include the additional attribute and method. So the additional attribute is January. So the title and authors are inherited from the super class using super keyword. When you are calling this function that gives access to the super class constructor or object, the method overriding. In this case, the method display info is already defined in the superclass, and the method is overriding in the subclass as well. And I don't need to just define the attributes of title and author repeatedly inside the book class, because this attributes are common for both classes. That's why we need to implement inheritance. It just inherits common features from the base class and add its own additional properties or attributes, that is January. And then access the superclass method through super function. Next, I'm going to implement another class, which is magazine. Magazine also has one attribute and inherits the other attributes, and also override the method display info from the base class. All right, I just finished implementing the magazine class, which inherits the properties and methods of library class, which is a base class. And this magazine class has one attribute that is issue number, in addition to the superclass attributes. So it just inherits the properties of the superclass because they have common attributes. That's why we need to define the common attributes in the base class, and we can inherit whatever defined in the base class in a subclass or child class. So this is called child class. All right. Next, I don't need to instantiate the objects of library, which is the base class. I just instantiate the subclasses and access all information about the book. Okay. So now let me instantiate the object. So this is what instantiating object for book one. And when you are instantiating object for book, you can pass the arguments of that object through constructor. So the title, the author, and this is what the genre. And when you are instantiating the object magazine, so the magazine has three attributes. Two attributes are inherited from the base class, title and author, and the other is issue number. So when you are calling that display info, which is overriding from the base class, so it just displays the information about the book. So these informations are displayed from the base class, and the other one information is printed from the subclass. So as you can see, the output book information includes title, author, genre, and magazine information includes title, author, and issue number. So this is what a simple implementation of inheritance, which is an object-oriented programming concept. So you can extend this project by adding more features such as library class to manage a collection of items or additional properties and methods to the existing classes. This should serve as a good starting point for understanding how inheritance works in Python object-oriented programming. So feel free to expand your knowledge by practicing and developing like this project. If you have any question, you can ask in the comment section of this tutorial. Don't forget to like, share, and subscribe. Write comments below. Thanks for watching.